Yes. So let's start. So I'd like to welcome everyone to the webinar. Today's topic is the Varnish API Engine, which is a brand new product which we just launched this month. So if there are any questions, you can use the sort of questions tab on GoToWebinar in order to ask questions. And from time to time, we'll see if we can answer the questions that are coming up. If not, we'll go through all the questions at the end of the webinar. So if you have any problems with the sound, or if the sound sounds distorted, please raise a question about that, and we'll try to address that. Okay, so in order to sort of give you a proper background on this, I thought I'll start first by giving you a bit of information about Varnish Cache. So Varnish Cache is the basis for the API engine, and that's why it's sort of nice to know what it is. So I mean, it's mostly known for being a high-performance web accelerator. The thing that's sort of quite unique about Varnish Cache is that it has this flexible configuration language, which is called VCL, and it sort of allows you to build applications inside of Varnish Cache. So it gives you, the VCL language gives you sort of possibilities to change HTTP transactions, and you have modules and you have other stuff, so you can actually build an application. And so the Varnish API engine is one out of several applications which we've built within the cache. Varnish Cache itself powers approximately 10% of the web, mostly in the top 10,000 websites, where sort of this scalability and performance are really, really important. And if we do some sort of rough calculations, we guess that approximately 20% of the web views on the web actually touch Varnish Cache at some point. A bit about sort of the company I work for. So with Varnish Software, we sort of like to position ourselves as the sort of company behind Varnish Cache. We make sure that sort of Varnish Cache has releases, and we do the release management. We do quite a bit of the development on it as well. We make our living by providing software and services around Varnish Cache, and we are based in LA, New York, London, Paris, Oslo, and Stockholm. So today I'm talking to you from Oslo, which is the sort of R&D headquarters of Varnish Software. The most of our customers are customers of what has to date been our sort of only product, which is Varnish Plus, which is our sort of spin on Varnish Cache. Basically, it's sort of a set of software and services aimed at the sort of top high end of the market. Products like enable you to easily manage Varnish Cache, to add high availability, and of course with the support. So things like that. Okay, so on towards today's topic. So the reason why we're doing something with APIs, I mean, there's been a massive increase of web-based APIs for the last 10 years. And I mean, mostly it's been about the mobile, sort of driven a lot of that adoption. But today also we've seen this whole Internet of Things coming up suddenly as sort of as a driver for APIs. It's also interesting to sort of to note the sort of popularity of microservices. So orchestrated use of web-based APIs becoming sort of an increasingly popular way to sort of to develop distributed applications. And just on a slight side note on sort of why microservices is having this why it's becoming so popular, it's basically because it's a sort of nice way of handling sort of complexity in a sort of complex application by having small independent APIs that are easy to develop. as probably, so those of you who work with software development, complexity has this sort of exponential cost to it. So we can actually see it in Varnish Cache development as well, where going from nothing to Varnish 1.0 took 9 months, whereas going from Varnish 3 to Varnish 4 took almost 3 years. And of course, most of the functionality was, a lot more functionality was added in sort of 1.0. I mean, that's where we got the majority of the product was in place in 1.0, whereas the change from 3 to 4 was rather incremental, but because of sort of the complexity of the code base, development velocity sort of slows down. You can just sort of, and we see organizations trying to mitigate this in some way by sort of having microservices. So, yes, but so what's an API manager? There's no like dictionary definition of what an API manager is, but there's a rough consensus of what it is. So if you can imagine an organization having a set of APIs. So in this example, we have 3 APIs, and then you have a bunch of consumers of those APIs, and of course those consumers will talk to all the APIs, and as you have like thousands of clients accessing your APIs, certain needs will arise for some sort of common services to be applied to those APIs. And first and foremost, I mean, security is one thing. Having access control on those APIs becomes increasingly important. But then also things like metering, throttling, things like that that need to be implemented across. And instead of implementing those features at every API, you instead sort of force the client to go through an API manager where you sort of terminate the HTTP connection there. You apply security, and then you sort of proxy the request back to the host that's actually hosting the API. So that's sort of our idea of what an API manager is. And why we are launching this thing? So I think the main driver is probably that the current market offerings are slow. They're really dead slow. So last year I was talking to a major news organization in the US, so one of the bigger ones, and they were struggling with performance with their current sort of API manager, and it was one of the sort of nice expensive ones in the upper right corner in the Magic Quadrant. And what they told me is that they couldn't get past 200 requests per second per server for the API manager. And so they had like performance requirements of somewhere in 5 to 15,000 requests per second, which was their sort of peak load. And that would mean that they would have to have anywhere from sort of 50 to 75 servers doing API management for a rather limited amount of actually backend APIs. So in their setup, the sort of API manager layer would be sort of just as fat as the sort of API layer behind it. And I think like a lot of this comes from sort of historical reasons why if we go back to sort of the beginning of the web-based APIs, where we have SOAP and such, and performance was typically measured in requests per hour, and nobody really was sort of using web-based APIs in any sort of performance in any application that was sort of built for performance. Since then, of course, a couple of things has happened. Is that one is that there's a lot more focus on performance these days than 10 or 15 years ago, and adoption has of course changed dramatically. I mean, you have the whole app ecosystem now, which are sort of they're all huge API consumers. and has driven the adoption of web-based APIs quite a bit. And what we feel is that the current market offerings haven't been able to sort of keep pace with the performance requirements that are in that market. And to some extent, I feel that we're at the beginning of the bending of the curve when it comes to sort of web API adoption. So I mean, the whole Internet of Things is going to change this and make the situation even worse. If you can imagine sort of every household in the UK or every other household in the UK buying something like a thermometer that's online, and that thermometer will sort of report the temperature once every 5 minutes or so, and suddenly you'll end up with sort of tens of thousands of API calls per second, as these API calls will sort of flood the system with data. Also, current market players they are quite expensive. Prices are very high. It's really hard to sort of get anywhere without spending $100,000 or $200,000 a year on licensing. And there's a reason for it as well. I mean, if you look on sort of the for instance the venture funded API manager providers. I think like Apigee has taken $170 million in venture capitalist funding, and of course that's not free money. Somebody wants that money back, and the way that they're trying to recuperate those money is, of course, by sort of passing that bill on to the client. And some of the models that they're using are also a bit restricting. So you can have a per RPS licensing. So you buy a license for doing maybe up to 1,000 or 1,500 API calls per second. And then you're sort of limited by that. And that means that you can't really let your API flourish the way you want it to, because the model is restricting you to stay below your allowed threshold. So a bit about how the product came about. 4 years ago, or 3 years ago, we started working on access control for web content. We did a bunch of paywalls in Varnish. So that was sort of the first sort of application that we built inside of Varnish. So, I mean, you all know what that sort of news site paywall look like these days. So it does basically authenticate and authorize the user to see the content, and if it is not allowed to see the content, they show you some sort of screen encouraging you to sort of sign up for a subscription. And for quite a few newspapers out there, a lot of that actually happens inside of Varnish. And of course, that's the reason why that's a good idea, is of course that you can leverage sort of caching in Varnish. So you don't have to actually pass the request back to the application server in order to have the application server do authentication and authorization. So that, yeah, and we felt that was a fairly successful product, and it sort of showcased how we can sort of do this for other applications as well. And then, as sort of APIs become more widespread, uses of web-based API become more widespread, we sort of, if we could sort of do the same thing there. I mean, the same protocols are being used. The access control schemes for news paywall is almost identical to APIs. I mean, there might be slight differences there, but overall, it's mostly the same thing. So we last year we built a prototype. We built this with a sort of large. There was a sort of Fortune 100 media conglomerate. I think they gave us performance requirements of 10,000 API calls per second. Internally, we bumped that to 20,000 in order to have some headroom. And the requirement also is this was supposed to be deployed on EC2. And after quite a bit of development, we were able to sort of deliver that prototype, and it was, I would say, quite a success. It went into production sometime after the summer, and it's still in production today. And yeah, with the regular peaks up to 10,000 API calls. So we're now at the point where we have a 1.0 release. The main sort of the difference from the prototype is that it's sort of it's no longer a prototype, so it has a certain it's a much more generic product. It doesn't sort of assume that you're this specific customer. So the things that we basically added to it was to add a sort of central server component that gives you the possibility to manage everything from a central server. We built APIs, so you can sort of manipulate the product through API calls. It would be rather, I would say, ironic to have an API manager that doesn't have an API. And we've been able to sort of leverage our statistics product, VCS, which is the sort of in-memory database for Varnish statistics, to be able to leverage that to do metering. We'll go a bit more in details about that later. So the core functionality that's currently in place. So it's the obvious sort of security bit. That's authentication. So making sure that you know who the client is, and then a sort of authorization layer. So then allowing that certain client access to a certain API or to a certain API call, and then metering. So that includes all sorts of sort of gathering all sorts of statistics of which clients are using what, how many API calls they are consuming, what the sort of response time that we are experiencing from our backends, error rates, all those things. And then there's throttling. So to be able to sort of put quotas on API usage, so you can sort of set a throttle rule on either a specific client or an API. That sort of so one specific client won't be able to sort of run your API into the ground by abusing it. And lastly, caching. Caching is sort of something we almost got for free here, since sort of this runs within Varnish, and Varnish already knows how to cache. So caching your API with the API engine is rather trivial. Design. So I'll hand over the microphone to Espen. So Espen is the lead developer on the API engine, and he'll now sort of tell you how it's built.
Hello. So I'm going to start to show you how we've designed it, and then I'm going to continue the presentation by actually installing it and demo how it works. So about the design. This is a typical production environment running the API engine. On top, we have the consumers. They send requests to our Varnish Cache layer. I'll come back to that in the next slide. These Varnish caches communicate with our centralized services, which is the management service, accounting service, and the statistics service. The management service holds all our API configuration, endpoint configuration, and API rules to access the APIs. The accounting service is used to count requests used for throttling. And we have the statistics service, which is used for real-time statistics, such as error rates and response times and stuff like that. Yeah. If we go and zoom into one of the Varnish Cache hosts, it basically looks like this. Varnish Cache is the core component. We have added a daemon which pulls configuration from the centralized configuration service, the REST API. The configuration is stored in a local database, and it is stored in VCL. We use the SQLite vmod to read the database from Varnish, and we use the memcached vmod to do throttling, global throttling across multiple Varnish hosts.
So I could just sort of inject a comment here. So I mean, the SQLite vmod, what it does is basically to embed SQLite into Varnish, and it allows us to store sort of the access rules within the SQLite engine within Varnish. That gives us sort of access to a relational database without having to go outside the process. So and that gives a huge performance boost. That means that when the API engine is sort of checking your credentials, that doesn't leave the Varnish cache memory space. So there's no sort of context switching or anything that needs to happen in order for that to happen.
Yep. Last, we have VCS, which is Varnish custom statistics to report statistics for each request.
Yeah, and that's also sort of written on a sort of very sort of performance with a very much a performance focus. So VCS tracks what a lot of things that happens inside of Varnish, and it does this through the shared memory log, which basically means that the whole sort of statistics reporting happens asynchronously, so that there's no way that sort of the statistics can sort of slow down the critical path of the API engine. So the API calls will go through independently of the statistics from a sort of performance point of view.
Okay. So to the demo. We'll start out with an environment like this. We have one consumer instance and one web server instance running an API. We'll send an HTTP request and see that it works. Then we will install API Engine and place it in front of our API. We'll send a HTTP request to API Engine. We will see that API Engine does authentication and authorization. It will strip the API key from the request. It will try to look up the request in the cache, and if it's not there, it will fetch the request or the object from the backend and cache it if possible. So I will switch screens now. Okay, we're back. Here we have our consumer instance in the top left corner, our web server with the API in the top right corner. On the bottom, we have the instance which we will install API Engine on. Nothing is installed there at the moment. So on the web server, we have an API running on port 80. So we can send a request to the web server from the consumer. In this demo, I'm going to use HTTP instead of curl because it looks slightly better for the demo. And the same request will look like this. Yeah.
So this is why you should all use HTTP instead of curl.
Yeah, thank you. Yeah, okay, so we got a 200 response from the web server. The API running here is just a dummy API, which will respond with the information about the request. It's used for testing only. Okay, what we can do now is to have a look at the access log in the API, and we will see the requests coming in. Yeah, and we can siege it as well, and we will get obviously lots of requests to our API, not protected or anything. Now it's time. Well, I can show you as well. These instances have been defined in my hosts file. So the web server is available on 10.0.10.10, and I also happen to have a service address which points to this IP. So I can access my API through api.demo. This is the same. Okay, so now it's time to install API Engine on my API Engine host. In production environments, we recommend running the API Engine on in a multi-host environment. But since this is a demo, I'm going to install all the components on one server, which means that this single server will run Varnish and the management services. Okay, so we will start by installing all the packages. These are the API Engine packages needed. The REST package is the centralized management service. The CLI package is our command line tool, which we will use to administer and configure the API Engine. The sync package contains the sync daemon, which will run on all of the Varnish Cache hosts. This is a meta package that will install the vmods needed. We will need Varnish Plus, and we will need memcached for accounting, and that's about it.
So like one of the goals for sort of the product is that you should be able to install it and have it up and running within an hour. So I mean, some of the sort of products that are out there, I think have you typically have to spend 2 hours of consulting time to actually get the product to work. And I've always been a sucker for sort of simplicity. And so we spend a lot of sort of resources on making sure that the product is easy to install.
Yeah, I've done this before as well. So I guess we will spend 5 minutes
yes.
instead. Okay, so the packages have been installed now. The REST interface is ready to go out of the box. It will listen to port 8080 by default. And we can connect to it using curl, but I'm going to use our CLI tool, which we also have installed. The REST interface comes with a default user, so the first thing we're doing is to change the username and the password. So our CLI comes with a default configuration file, which contains the URL to management and the default username and password. Also, it contains the path to a cache file where it will store the token used after authentication. So the first thing I'll do is to copy this file to my home directory and secure it. Now I'm going to request a token, which I use the API Engine command for. The token has now been stored in my cache file. So the cache file is in my home directory. We can actually have a look at it. Okay. I'll reset the password to my secrets. And the response here is the information about my user, which is currently the username is admin and the email is admin@example.com. So let's change that as well. Like this. My username is now Espen, and I've changed my email address. The email address will be used to recover the password, so it's a good idea to have a proper email address set. I also need, well, I can try to log in again, which will fail because now I have updated my password, but I have not updated my configuration file. So let's update the configuration file with my new username and password. This, and we can try to log in again. Great. Okay, so now the REST API is running. We have a user and we have disabled the default admin account. Now it's time to create a user for the sync daemon. The sync daemon will need to authenticate as well, since it is designed to run on other hosts. So there it goes. We create a user called sync with a reader role, which means it has read-only access. And we use a sysadmin email address in case we need to recover the password. I didn't specify a password there, which means that I got it automatically generated. The username and password must be put in the sync configuration file. Notice that this sync daemon or this sync configuration file also has the address to the REST interface. Since we're running this on a single host, there's no need to update it, but if it's going to be run on external hosts, this endpoint must be updated. Okay. Then we can start the sync daemon. Now we have the REST interface running, we have my user, and we have the sync daemon running. It is also authenticating to the REST API. Now it's time to configure Varnish. I start by getting it to listen to port 80 instead of the default 6081. And by default, Varnish is shipped with the following VCL. and we need to include our API engine configuration instead of using the default one. This configuration is shipped with install documentation, so it should be easy to get going. I can explain the parts of it. First, we import the vmods needed. We initialize the memcached vmod and get it to connect to memcached running locally. We set some parameters for the API engine. We can choose to log errors to syslog. We recommend not to because of performance. We can choose to accept requests without an API key set, meaning unauthorized requests. We can accept requests if there's an error with our database, and we can choose to accept requests if our memcached layer is unavailable. And in the end, we include our API engine VCL file. Okay, so Varnish is configured and it's ready to start. We can also start memcached. Okay, and we're ready to start configuring it. Now I'm going to add our web server, our API running on the web server. So at first we need to create a directory. In Varnish, a directory is a load balancer, so to speak. So we prepare it to for horizontally scaling the web server if needed in the future. Can add a description for it. And then we're going to add the web server to this directory. So we'll use the IP address. And we'll attach it to the directory. Now it's time to add the web application or our API. So here we specify which service address we're going to use, which is API demo, and it will access the URL on the top root. So the description is top level endpoints. Okay, now we are ready to start adding access rules. So we will add a rule for this newly created endpoint. And we say that this rule accepts 2 requests per 10 seconds with the key secret.
Yeah. You can notice the syntax there with 2R10. So that basically allows you to set a certain number of requests per and a certain number of seconds. So that means that you can express this as request per seconds, or if you want to express it in requests per minute, you use, for instance, 5R60, and you'll have 5 requests per 60 seconds, or 1,000 or 3,600, and you'll have 1,000 requests per hour. So a rather flexible way of describing the throttling.
Yep. So now we're ready to send requests to our API through the API engine. First, I'm going to update my host file to make sure that the requests to api.demo go through API engine.
There was a question from Eugene here on how can we know what requests per hour we need. So, I mean, that's sort of a hard question for us to answer because we don't know what's the need of the API. But I mean, if you're a consumer of the API is a sort of public application, you should do some rough napkin calculations on how many clients you expect. What's the number of API calls that you expect your API to be able to handle, and then sort of divide it up and see if that is a reasonable figure.
Okay. So the host file has been updated, and I can send requests to api.demo. Without any API keys for this request, it will fail. Varnish will fail this request, and it will never hit our API. We can add the API key as a query parameter, and you can see that it hits the API. Or we can add the API key as a request header. Notice that this request went through without the backend being hit twice. So the request went to the backend once, and the client requested the URL twice. So we can run 3 requests in a row, and we see that we get a 429 response with a too many requests, which means we have been throttled. After 10 seconds, we can send more requests. Yep, so this was the first part of, or the sort of the main first part of the demo. We can go back to our API engine. You can see that we have only one endpoint configured. Let's configure another one on the same host. This API is really this API has a part of it which is expensive to run, so we would like to limit the amount of requests even more. Like this. When we show the endpoints, we see that we have 2 of them. We can create a rule for the second endpoint. We will only allow 1 request per 30 seconds for this endpoint, which is really strict. And we'll have the same API key. So here, back on our consumer, we can run 1 request to the expensive part of our API. We can't run anymore, but we can still run requests to the rest of our API. But the expensive part is still blocked. This is because we use both rules depending on the URL in the request.
So there was a question from Brett. If you need to define all of your endpoints within API Engine?
Yes. It depends what you can. It depends what an endpoint is. You can define each API as one endpoint. That will be fine. You don't need to define all your endpoints within each API as an endpoint.
So, for instance, if you have like if you consider one API endpoint like a virtual host, you would need one to have that defined once. But if you have then multiple APIs behind a virtual host, you don't need to define all of them.
No. An example is if you have one API with two functions. The first function is list, and the second one is search.
Yeah.
The search part of it will obviously be more expensive than just listing. So then you might want to add two endpoints to that single API.
Yeah, in order to have different throttle rules.
Yeah, because then you can have different throttle rules using the same API key, but different amount of requests allowed per period.
Right. There's another question from Dan. If there is a way to import existing access tokens or to bulk create them, they have 5,000 keys at the moment.
Yeah. Using the CLI, it's possible to bulk create keys. It is also possible to use the API, the REST API in the central management directly. I would guess it's easier to use the CLI, but the possibility of using the API is there.
Yeah. So I mean, you can get around it by using the API or by shell scripting.
Yeah.
Is there a way? This was a question from Alan. If there's a way to disallow caching for an endpoint, but still route the request through Varnish and the access rules?
Yes. If we go back to our configuration or our VCL configuration file, we include API Engine last in this file. Includes in VCL will just merge the configuration file in this
appendage to each other.
Yeah. And it's possible to have custom VCL before and after the VCL configuration for the API Engine. So it's this product only covers authentication, throttling, authorization, and metering, and the traffic flow or the VCL flow will still be the same. You can have custom configuration before and after. API Engine will not terminate requests. It will sort of let the traffic or the requests flow through our API Engine configuration, and if it pops out on the other end in the VCL configuration, then it's sort of accepted.
Yeah. So I mean, so there's a sort of pretty vanilla Varnish here beneath it. So you have still all the flexibility that VCL gives you, to override policy. So you could do, if you want to sort of disable caching generally, you can do that by for instance, adding a parameter to Varnish so that the default cache will be 0, and then unless the backend supplies caching headers, Varnish will not cache it. And even if Varnish supplies caching headers, you still have the possibility of overriding those in that VCL. So question from Eugene was if there's any wildcard support.
Not currently, but if you have a look at the endpoint, we specify the host and the URL. This is a from left to right matching,
substring matching,
substring matching. So we can do. That's why I could do foo.
Yeah.
This will match this endpoint.
Yeah.
So we don't have wildcards, but it's
substring matching. Yeah. So if you, for instance, were to access /expensive2, that would hit the expensive rule.
Yeah. and we can't.
And you'll get denied there.
Yeah.
Okay. Great. So it's sort of it sort of plugs nicely into sort of the naturally hierarchical buildup of your URL space. Okay. So question from Warwick. The demo is very impressive. So good work, Espen. The installation and configuration is compelling compared to products currently in the market. Please say, if there's time, more about the global distributed deployments and latency and centralized control and metering and configuration.
Okay. So how we have designed it, a bit on that. We have tried as much as possible to keep all processing local on each Varnish cache host. That's why we replicate the database, for example, onto each of the Varnish cache hosts. That way we avoid callouts there. Regarding memcached, we need to do the callout to have support for global counters. So imagine if we have 10 hosts running Varnish Cache, they need to have the same set of counters so for the throttles to be
the throttle state needs to be cluster-wide.
Yeah. The nice thing about memcached is that we can have a pool of instances, and we use consistent hashing on the client side, the client here being Varnish Cache, so that Varnish will actually connect to the various memcached hosts directly to avoid bottlenecks there as well. You will get the network latency between the Varnish cache host and the memcached host, but it will sort of scale linearly since you can add more memcached hosts at the same time when you add the Varnish hosts. Multi-location deployments will work, but due to the added network latency, we recommend having local installations in each location, so that you have a set of global counters in each location or data center if you want, and then you can use geo IP or entire data center active passive modes to direct the traffic to the various API Engine environments.
Yeah, but you could have like a central management processes so that the rules are global.
Yeah.
But then you have let's say one installation US West and one US East and one in Ireland and one in Singapore, and those will have their own memcaches, so they will have independent throttle states.
Yeah.
But as long as you're sort of comfortable with that, knowing that the client potentially could bypass the throttle rules by using multiple data centers, then that will work fine.
Yeah. And you still have one central place to manage
everything. Yeah.
Yeah.
Okay. Great. I hope you are happy with that answer, Warwick. Yeah, the question from Dan, wildcards again, that's been answered. Brett asks if there's support for OAuth.
OAuth is currently not supported out of the box, but we are considering it, of course, and it seems at this point that implementing OAuth should be relatively easy. We will have to discuss if we're going to include it in the product, but since we have this configuration here where we can do custom stuff before and after, we will manage to get OAuth support.
Yeah. So you could do. So there are recipes floating around on how to sort of do OAuth in Varnish itself, and you could do the OAuth strip the OAuth in Varnish and then hand it over to the API engine. So it's sort of, but I mean, obviously it will get a bit more involved. But but it's currently it's possible, and we sort of at a later point we will be sort of hopefully adding native OAuth support.
Yeah.
Okay, a question from Henry Robert. If this can be bounded to Identity Manager, which supports SAML or OAuth authorization and token management, and that I think we've answered that. Not entirely sure on SAML. And the second questions are SOAP APIs supported, and can they be cached? So SOAP APIs, if I recall correctly, they are not very cache friendly. I think they always use post requests, and the HTTP spec disallows caching of post requests. So you can't cache a SOAP API, but you can sort of manage it through the API engine. But you will not be able to do the caching. So, question from Kevin. It's geared toward larger companies currently. That's absolutely correct. So, I mean, the main thing behind the product idea behind the product is performance. So we are currently sort of our main focus is to address the part of the market where you have multiple thousands of requests per second. And that's but as sort of the product matures and we'll come up with a sort of graphical UI, it's definitely something that we hope to address sort of the smaller and medium enterprises as well. Question from Dan: if the access token can be passed in a header rather than the request string.
Yep, this is what we do here.
If you scroll up, you can show the HTTP request there.
Yeah.
Is it? Yeah, you don't see the request. Yes.
This is the request header.
Yeah. So you can add it as a API token. It can be added as a request header. Yes. So, question from Justin relating to the OAuth question: is it possible to use Varnish to verify and crack open a JVT and pass on part of the content to the backend server? I have no idea what a JVT is. But we should probably make a note of that question, and hopefully we'll be able to answer that question next time. Does it implement a way of purging cache sharing the same object or content across different endpoints, or must that be implemented in Varnish VCL? So you must add the sort of relevant VCL to enable purging. Yes. Absolutely. And it will also work with some of our other products like Varnish High Availability. So if you want sort of content replication between these varnishes, that will actually work quite nicely. Another question from Dan: does it support Varnish 3 or 4?
Support both.
Supports both, so it generates configuration for both. So as you can see sort of on the terminal now, this VCL includes the API Engine v4.0 VCL, and in a Varnish 3 installation, you just include the 3.0 VCL instead. Question from Warwick: cost are annual? It's annually subscription based. And a question from Justin again on JSON Web Token, signed cookie with the result of authentication and authorization. So you can use signed cookies, but you will need to sort of set up that in VCL before in the VCL. So basically just sort of verify the signed cookie in VCL using the digest vmod, and then you just sort of pass that on as the key and let the API engine handle the rest. So it's sort of, it should be rather flexible. And then yes, you can get a trial. Sales will be the natural sort of point of contact. Or if that seems scary, you can always reach out to me directly, and I'll get you set up.
Okay. I think we can finish the demo there.
Yeah.
And go back to the presentation.
Oh, it's green.
And we're back. Yeah, okay, so we did this. And demo is done. Okay, so to performance. So
yeah, so we done some sort of preliminary performance tests. So deployed on Amazon EC2 on a sort of large instance. We found it we could do 10,000 requests per second per EC2 node. That's probably quite a bit higher on a bare metal deployment. Yeah, and I mean what the feedback so far is that we're somewhere between 10 to 100 times faster than sort of competing products, which is something that we're really proud of. So what's next for sort of the product? So obviously, sort of mentioned already, web interface for management. That will include sort of visualizations of real-time statistics. And also sort of the possibility to persist those statistics. So currently, sort of the API engine will only track statistics using the sort of in-memory database of VCS, but work is sort of underway to in order to sort of pipe those data into permanent storage, and then be able to sort of query it. And also, I think we can expect further sort of performance improvements. Yeah, and that's basically the end of the presentation. Oh, and a question from Victor. If the difference between API Sync and Varnish HA. So Varnish HA replicates objects between Varnish nodes, Varnish Cache nodes. The API Sync basically sort of what it does is sort of grab the central server, download the configuration, and sort of locally configure that node. And I mean, Espen sort of mentioned this, but the way we do that is so there's as few external calls as possible when we're processing the request. So as much data, as much it should be as independent as possible. So yeah, I mean, Varnish typically sort of answers in a matter of microseconds, but every sort of network call will sort of delay that. Yeah. Size of the EC2 node, I think it was a large node.
Extra large, I think.
Yeah. Extra large node, yeah. Okay. So guys, I think I forgot to include my contact information here, but it should be very, very easy to find it if you should need it. Just reach out to me on email or Twitter, or if you Google it, you can also find my phone number. So that should be easy. Also, sort of our VP of sales just stuck in his head in the door, and I guess. And if there's questions about pricing, sales at Varnish Software will be very happy to answer your questions. Okay, great. So thank you very much for attending, and have a good day.